So in the previous video we have understood the working how the circuit works for the monostable multivibrator, and let's see the next application, that is a stable multivibrator. And as I have told, a stable multivibrator which does where both the on as well as the off condition are in the unstable state. That is, it won't stay back for in the on period or in the off period continuously without any external trigger. It will keep changing its on and off state. So that is why it is a astable condition. So how to generate this astable condition is the circuit, as I have told, it is the same circuit. So up to here it is our 555 timer circuit with a threshold as well as a trigger inputs. Now here the Q is given to a transistor, and through this transistor here it is connected with the resistors to the VCC, and there is a capacitor connected. In the previous case the capacitor was connected to only the threshold line. Here the capacitor is connected to the trigger line also. So by this itself I hope you can analyze or you can understand the working. Let's follow the same previous procedure. So initially let us imagine it is in the output will be 1. This output when it is 1, what happens when the output is 1? Here we know that it is connected to our gate of the transistor, and the gate of the transistor when it is given with a very high, here it goes to the saturation. When it is go to the saturation, we know that the capacitor will be discharging, so there is no path for the charging of the capacitor, so it starts discharging. When it starts discharging at a particular time, when it starts discharging at a particular time, what happens? It goes below 1/3 VCC. So when it goes below 1/3 VCC, now this trigger line goes below 1/3 VCC. That makes our second comparator goes high. So when the second comparator now goes to high, what happens to our what happens to our R pin? R pin is given with a high. That means it is an output state will be 0. Sorry, yeah, this Q will be 0. Yes, so that when Q is 0, we know that Q bar will be in the high condition, that is our Q bar will be high. So we can see here our output, that is Q bar, is in the high. So now this 0 goes to the transistor gate, which makes the transistor off when there is no connection here. When it makes the transistor off when there is no connection here, what happens? Our capacitor starts charging through this path. Sorry, it starts charging through this path. So through this path it starts charging. Now when it starts charging and our output, that is our Q bar, is equal to high at a particular time, at some time our the capacitor charging voltage goes above 2/3 VCC. Now when it goes above 2/3 VCC, that will be going to our first comparator, and our first comparator will be high. Now when the first comparator is high, the set becomes equal to high. That means our output becomes equal to 1, that is our Q bar becomes equal to 1. It is not our Q becomes equal to 1, not our Q bar. So when this Q becomes equal to 1, what happens to our Q bar? Our Q bar goes to off condition. So when this Q is 1, this is going to again our gate of our transistor, and the gate of the transistor is given with a high, which makes the transistor to the saturation region. Because of this saturation, what happens? Our capacitor starts discharging in this path. So this will be in the off condition, and it's the capacitor starts discharging. While discharging, when it goes less than 1/3 VCC, again what happens? Our second comparator becomes equal to high. When the second comparator becomes equal to high, the Q output becomes equal to 0. When Q output becomes equal to 0, Q bar becomes equal to 1. So Q bar becomes equal to 1, and our capacitor starts charging. Why capacitor starts charging? Because this 0 goes to the gate of the transistor. When it goes to the gate of the transistor, the transistor will be off. So when there is no path for discharging, it will form a path for charging through this, as we had seen previously, and this continues. Again it goes beyond 2 by 3 VCC. Comparator 1 will be high, and next it start discharging after a particular time, and here it goes below 1 by 3. It will start discharging, and so on. So this is how our stable multivibrator works. Both the notes I have, I'll be putting it in the Moodle. Yeah.